Hello everyone. In this video we're going to go over the solutions of the worksheet for practice 6.2 and 6.3. And so first we have a region that is bounded between the graphics of the parabola y equals x squared and the line y equals 2x. And so when we sketch the solid of this region rotating about the x-axis, notice that we have this region where we have on top, we have the line equals y equals 2x, and below we have the y equals x squared parabola. When we rotate this close to the x-axis, then we're going to have this solid. Now, notice that the intersection of x squared and y equals 2 is going to be in x equals 0 and x equals 2, since in both of them, the values are going to coincide. In 0, they're both 0, and in 2, they're both 4. So this is the points that we're going to use for defining the dishwasher method. Now the dishwasher method, remember, is pi r squared, the inner radius minus the outer radius. And so here the radius that we have on top is given by the function y equals 2x, and the radius that we have below is given by x squared. So that's why the area that we have here is represented by pi to x squared minus pi x squared squared. And that's going to give me 4 pi x squared minus pi x to the 4. We can plug that in the formula for the volume, and then we have this volume formula for the dishwasher method. Now let's consider the same solid, but this time we're going to rotate the region around the x-axis. And then we're going to use the definite integral to represent the volume by the dish and washer method. Since this is still perpendicular to the axis of revolution, then we're still using the dishwasher method, and then we need to calculate the inner radius and the outer radius, then we need to change the variables that we're using. Notice that y equals x squared becomes x equals a square root of y. And y equals 2x becomes x equals 1/2 of y. Now, if we use that in the area, we notice that a square root of y now is going to, which is this function here, now is going to be the outer radius. So it's going to be the biggest radius here. And the smallest radius is going to be given by this function here, the line 1/2 of y. So when calculating the area, we have pi, a square root of y squared, minus pi, 1/2 of y squared. And then again, the functions are coincided when x equals 2, which reflects to being y equals 4 here. So now the integral changes to being the integral from 0 to 4 of pi y minus pi over 4 y squared. Now question number 3 take us so we can sketch the solid created by rotating the region around y equals minus 2. So now we're back on the first case, but instead of having the x-axis, we're moving the axis of revolution to the line y equals minus 2. So that's going to be exactly the same idea, pi r squared, but we're going to have to change the axis of revolution. The area is the same. We're still going to go from 0 to 2. And we're still revolutionizing this area around given axis, which is in this case the y equals minus 2 line. Notice that the difference now is that for the outer radius starts on the top being 2x. Now it's not only 2x, but it's 2x plus 2, since we have to add the distance from the x-axis to the minus 2 line. The same thing happens for x squared. And now is x squared minus minus 2, and so that is the radius that we use in each of the cases for setting up the dishwasher method. Now, if we want to create the solid of revolution but doing it by cylindrical shells, then remember that here, since we're taking the y-axis, then to create a cylindrical shell of this, then we need to consider what's going to be the parallel segment that we're going to use to determine our radius. The distance, of course, is going to be x, since the radius is going to be measured to a certain distance x. So we have that the 2 pi r by h, volume of the cylinder here, is 2 pi x, and then we got the outer, which is going to be in this case 2x minus the inner, which is going to be x squared. Notice that we're still going in the order of priority of who's on top and who's on the bottom here. And since we're considering everything in terms of x, then this is 2x minus x squared. And that's going to define the height of the cylinder here. Now, then expressing this volume in terms of my formula will be the integral from 0 to 2 of 2 pi x, 2x minus x squared. And so once that we compute this, we obtain the cylindrical shell. Now we can also consider what happens if we rotate this region about the x-axis and find a definite integral that represents the volume using cylindrical shells. So notice that now the cylindrical shells are going to be parallel to the x-axis, and we're going to need to transform again everything in terms of y. So y equals x squared transforming to x equals the square root of y, and y equals to x transforming x equals 1/2 of y. And so again, we can check what is the height of the cylinder here. The cylinder piece will be, first we're going to have on top square root of y, which is now this one here, and then the bottom we're going to have 1/2 of y. And the distance from the cylinder is still going to be the measure y, which is the measure from the x-axis to the edge of the cylinder. And so by that, my formula is going to be the integral from 0 to 4 of 2 pi y, the square root of y minus 1/2 of y dy. Now, we can also do something similar to what we did before, and using cylindrical shells, we can move the axis of revolution. So if we sketch the solid created by rotating the region around the x equals minus 2 axis and find a definite integral using cylindrical shells, we're going to notice that initially this region here is going to be revolving now around this x-axis of revolution. Now this is a cylindrical shell as an area, so we have x as the distance plus minus 2. So it's going to be x plus 2 is going to be the radius, and so that's what we have here. And then again, for the area and for the height of the cylinder, we only have 2x minus x squared. And so that will be pretty much the only changes that it has when we're rotating the cylinder around the line x equals minus 2. Now finally, if we suppose that this same region is the base of a solid whose cross-section is cut perpendicular to the x-axis and those cuts are squares, we want to find out the definite integral that represents the volume of this solid. Remember that if this is a cross-section, then we're not revolutionizing around, we're just thinking of this as a slice. And if we're doing that, then the height of this is going to be simply the difference between the two functions. So we're going to have 2x minus x squared, and this is going to measure the base of the square. And remember, the area of a square is just h squared, or the base square. And so this will be represented by the integral from 0 to 2 of 2x minus x squared. This is what we call, remember, the method of slices. So this is the end of worksheet for week 1. And next week, we're going to be checking out some different integration methods that we're going to be using for more integration